Hello, welcome to my YouTube channel, Decoding Universe with Scientists. So I have Jagdeesh. So Jagdeesh, can you give a brief introduction about yourself?
Hello, myself Jagadesh from Tamil Nadu. I did my BSc from Madras University and MSc from NIT Trichy. And recently I got selected for post MSc Diploma in Radiological Physics at BARC. So I'm currently doing that course.
So Jagdeesh, you qualified GATE examination. So and you were called for interview at various institute. One of them was PRL. So can you share some of the questions that were asked in PRL?
Yes, sure. In PRL, I was giving interview for theoretical physics department, for the post of PhD, junior. I mean JRF. They started with quantum mechanics, and it was about a complete set of mutually commuting operators, and basically
First question they asked was
quantum.
regarding the graph. So can you
Okay,
discuss that graph?
sure. So they gave me a function which was 1 over 1 minus x square, and they just asked me to integrate this function
First they
from minus infinity
asked
to
to draw
infinity.
this graph.
Yes.
So can you draw?
Yes. Before integrating, they asked me to draw the graph, and it becomes indefinite.
Plus minus 1 it will be infinity.
Infinity.
It shoots to infinity.
Yes. And it approaches 0 from negative axis.
And 0 if you
Yes.
take x to be minus infinity or plus
Yes.
infinity. So yeah.
So it approaches 0
And from the same thing.
from, yes.
And otherwise it will be
Not this flat, but yes.
like parabola, something like parabola.
Yes.
So this is minus 1 and this is plus 1.
Yes. And the question was whether the integral exists. First question was whether the integral exists. I said it does. And then they asked, so what is the value? I was trying to solve, but I couldn't solve actually. And then they shifted to a different integral, a contour integral.
This contour integral, yeah.
This contour integral, and the contour is nothing but a unit circle centered at origin. This is just 1 over z, and I was proceeding to solve this. While I was solving, I just did multiplied the conjugate of z on both denominator and numerator, and they stopped me there, and then they asked me if I have seen this function anywhere. Yes, like in physics. I said no, and then they asked if this function has anything to do with this, and I said I can't really tell. So yes, they actually moved on to the next topics.
So the next question they asked was regarding the laser.
Yes, lasers.
Lasers.
And lasers, they started with very basic questions like how it actually works and why population inversion is necessary. But yes, while I was explaining, I was saying that basically I was explaining stimulated emission. And for stimulated emission to happen, the incoming photon should have frequency that is going to match this energy difference, or energy that is going to match this energy difference. So they riddled me. They said, if you want to build a laser, you already require a photon source of definite frequency. So to build a laser, you require a laser. They were asking me that question, and I really couldn't answer that. I said we can give a range of frequencies like white light. This is just going to excite. Yeah, white light consists range of frequencies. They didn't seem to be satisfied with the answer, and they asked if we can achieve the population inversion by applying heat. I said yes, and one of them laughed. Probably it's a wrong answer. I am very weak in solid state physics, not just any applied physics. Yes, and I was applying for theoretical physics.
And the next interview you gave for diploma DRP course, postgraduate diploma in radiological physics. So in that you were asked some questions. So for that I will ask him the questions and he will try to answer. So in that the first question was, so suppose you have a capacitor in which one of the plate is have a bump. So can you draw? So in between there is a pump. Yeah, there is a pump here. So can you draw the electric field? So suppose this is the lower plate is grounded. It's grounded, and the upper plate is at 10 volt potential.
Minus 10.
Yeah, it's minus 10 volt. So can you draw the electric field lines?
Basically, the electric fields that are originating from a conductor should be perpendicular, electrostatic field, and otherwise it will create a moment of charges, and that will no longer be electrostatics. So basically, you can draw some little perpendiculars everywhere. This is what I did, and I just joined like everything.
So it's literally perpendicular.
Yes. The thing is, you have to say that you have drawn in such a way. Yes, they made the conductor in perpendicular angle, and and then they asked me to draw equipotential surfaces, especially for 1, 2, 3 electron volts. So I proceeded by saying that the equipotential surfaces will be perpendicular to the electric field, and here I am just drawing equipotential lines. It's just projected in another axis, and you can think of it as like this. Again, the angles between these two curves are perpendicular 90 degrees, and for 1 volt. Similarly, you will have for 2 volt and 3 volt.
Minus 1, minus 1.
Yes. Minus 1. So minus 3 volt will go somewhere here like this.
Okay. Now suppose I have a electron just in the middle of the bomb, and it has given some initial kinetic energy of 3 electron volt. So what will be the trajectory of that electron?
So the electron has been released here with an initial kinetic energy of 3 electron volt in vertically upward direction. And basically it will start feel a repulsive force because of this conductor, and this is grounded. This is a 0 volt.
Yeah, so electric field is in
opposite. Yes,
you have opposite force.
Opposite. Yes,
Downward
oppose
force
the
it will experience. Okay.
oppose the moment of charge, and basically it will keep losing its kinetic energy. Initially it was 3 electron volts. By the time it reaches the equipotential surface of 3 volt, it would have converted all of its kinetic energy into potential energy, and it will stop here, and because of repulsive force it will start going down. Yes, so basically it will rise up and then goes down. It stops at 3 volt, the equipotential surface of 3 volt.
And the other question they ask, was regarding drawing the graph of sin x and sin square x on the same. That is easy, and you must have drawn that. So you can try that graph by your own.
I would like to. I would just like to add a point. What they were expecting was to draw it in the same graph, and if you draw sin x like this, for sin squared x, and the maximum value should be
Plus one,
plus 1. For sin squared, it's going to be plus 1.
Yeah.
And for in between values, for like values lesser than 1, the square takes lesser value. So basically just expect this thing.
Yeah.
Yes, it goes down.
Yeah.
Yes.
So in the next question they ask from quantum mechanics. So in suppose in particle in a box, the position of the particle is take the continuous value. So what about the momentum of the particle in that case? Can you answer?
This here is take it. It was about particle in a box, and the whole system is in ground state. Infinity.
Infinite potential.
Yes, and for ground state wave function, we know that this is x-axis. Ground state wave function looks like this without any nodes. So if it was a pure sine wave, we know the ground state wave function is sine function. If it was purely sine extending to infinity in both the directions, and then we can say that it has some finite frequency and it has a finite momentum. But since it has discontinuity near, not actually, wave function is continuous. What I meant to say is it's not purely sine. Pure sine would have continued like this, but it is becoming 0.
It's boundary condition because of boundary condition.
Yes, because of boundary conditions. It should vanish at near the infinite potential walls. So yes, and momentum space wave function is just Fourier transform of space wave function, position space wave function I mean. So when you take momentum like Fourier transform, you will find, let's say this is momentum space wave function plotted for different values of momentum, and these values of h bar k, minus h bar k, and plus h bar k, where k, we know it is usually defined as
2 pi.
Yes.
2 pi by L.
2
Pi
n
by L.
by L, and n here is 1.
Quantum number.
Here it is 1
It is
because we are dealing with ground state. If it was pure sine wave, we would expect one frequency here, one here, but it is not. But it is so close that the wave function will look like this. Not actually this. It oscillates like this.
It's like sync function.
Yes. I don't know how it looks here.
Okay.
Yes. It oscillates like this, and the most probable values are the minus h cross k. Yes. Principally, it can take any value of momentum from minus infinity to infinity. It is continuous, and but the most probable values are minus h bar and plus h bar k.
So suppose you have given 3 nuclei. Two of them are having the same value of Z atomic number, but different Q values, and 2 of them are having same Q but different atomic number. So you can just draw 3 nuclei. So you can take
X,
80.
Y, Z or something,
Yeah.
and
This
they
is 90,
90,
90,
90,
and this is 92.
just okay, 92.
Yeah. So two of them have the same atomic number.
Yes,
And
they have
different
Q values are different. Let's say
different.
Q1 and Q2,
Yeah.
and
these two have
same Q values.
same Q value. Same Q.
Again Q2.
Yeah. So can you arrange these nuclei according to their half-life
Half-lives.
in ascending orders?
Yes. For different Q values, we can use Geiger-Nuttall law.
Yeah.
For higher Q values, let's say if Q1 is higher than Q2, higher Q values will have lesser T halves.
Lesser.
Yes. So T half of this,
Mhm.
let's say X, will be lesser than T half of Y.
Yeah.
And here, even though the Q values are same for Y and Z, atomic numbers are different, which means the Coulomb barrier by gamma theory of alpha decay is higher for Z.
Yeah.
So more the Coulomb barrier, lesser will be the probability of decay, so longer will be the half-life. And then we can say, so it will have longer half-life than Y. So it goes like this, T half of Z.
Okay, nice. So now coming to the statistical mechanics question. So suppose I have a two-state isolated system. And the system contains n particles. So can you drive the value for total internal energy of the system?
So basically we have an isolated system with n particles, and it is a two-state system. I proceeded by deriving the partition function for the system. We can easily write down that.
Yeah.
First, we can write down the one particle partition function, and then for n particles we can extend. And they have mentioned these are distinguishable particles. So yes, just raise to the power of n. And internal energy,
you can use internal energy formula.
Yes, formula for internal energy. This beta is kV Boltzmann constant time temperature, and ln of Z.
Beta is 1 by kT.
Yeah, 1 by kT.
Now coming to interview of technical officer, and which you have been selected for the post. We will discuss the question regarding the question that were asked in TO interview. So the first question in TO was how can you differentiate between a semiconductor and a metal if they are kept in a black box? Can you use an experiment to differentiate between them?
Just for completeness, if you can see the metals and semiconductors, usually metals are shiny and semiconductors are not so shiny. They look very plastic. So you can easily differentiate with the optical properties. But the question was that what if they look the same, or what if you cannot see the material? And I was actually stuck with this question, and they gave me a hint. Can you play with temperature? And then yes, it's easy. Conductors, resistance of conductors or resistivity of conductors increases with temperature, and it decreases for semiconductors. And then they asked me what would be the temperature dependence of the resistivity for semiconductors. I said I don't know. I know it actually decreases, but I don't know the exact form of it. And then they helped me. They actually asked me what is the origin of this decrease in resistivity as we increase the temperature. And I was explaining with band theory, basically the free charge carriers or charge carriers in conduction band increases with increasing temperature, and that will that will give rise to increased conductivity or decreased resistivity. So from this, they ask if you can predict the trend of temperature dependence, and then I gave this answer. If this is the energy gap Eg, and yes, the distribution of particles in this case, in simplest case, it would be Maxwell-Boltzmann distribution. Even though these are electrons, they will form Fermi. It's for simplicity we can assume it's Maxwell-Boltzmann distribution for very high temperatures, let's say. And I just said that as we increase the temperature, you will find more charge carriers.
Conduction band.
Yes. And from this, I was able to draw the actual resistivity dependence, temperature dependence of resistivity. I did as exponential, and they seem to be satisfied.
This is for semiconductors.
Yes, for semiconductors.
So can you explain Bohr's correspondence principle?
Bohr's correspondence principle says as we increase the quantum numbers of a discrete system or bound system, the solutions.
Energy levels decreases and it seems to be like
yes.
continuous.
Yeah.
Values. So if you can take an example to explain, for like example of a particle in a box. So you can write the energy eigenvalue to be En equals to.
Okay, for particle in a box, En
pi square.
pi square h cross square
2m
2m
n square.
n square
L
r square.
or and A is the width of the box.
Yes. And as you keep increasing the value of n, you will find that the spacing between two different values keeps decreasing, and then for very high values of n, for sufficiently large, which is determined, what is meant by sufficiently large is determined by mass and the dimensions of the box, mass of the particle and dimension of the box. So yes, for such sufficiently large n's, the difference between two energy values is so negligible, and you can treat them as continuous values, and we can say it has reached the classical limit, or in other words, you can also take h bar to tend to 0 and obtain classical results using quantum mechanics.
And the next question was, suppose you have a classical particle in a harmonic potential. So what will the probability density function for that particle can you derive?
By classical mechanics, we can do some intuitive arguments. Let's say this is
This is a potential profile.
Yes.
For harmonic oscillator.
For harmonic oscillator, I just drawn x square or half k x square, and we know that the particle has maximum velocity near origin, and let's say this is the total energy of the particle, and this will be the turning points, and particle has 0 velocity at the turning points, and the maximum velocity should correspond to this probability, because we cannot detect the particle if it moves very fast. So this will correspond to minimum probability, and this will correspond to maximum probability, because they are reaching
so this
0 velocities.
To
minimum probability,
and this the ending
maximum,
corresponds to
yes.
maximum.
And 0 for the outside in classical mechanics. Basically, they cannot escape the well. So it would go like something like this. probability function as a function of x.
So if you, so suppose this particle has the amplitude a, this is plus a and this is minus a and this is minus 0. So in this region, suppose I take a time interval, I take this dx distance. So the velocity of particle dx by dt, this is the velocity of the particle given by this omega a square minus under root square. This is my velocity. So the probability of finding the particle in this region is given by dt over t half by 2. So the particle is taking t time from going from this position to this position, because t is the total time interval. So that's why I have divided by 2, and my dt, you can calculate dt from here and you will get the probability function, and it will come to be like this. Okay. So you are selected for this TU position. So do you have any idea about the work of a technical officer in BRC?
Actually, myself, I am confused myself. I am just looking to get some advice from seniors. I have a gut feeling that radiological physics field of medical physics is better. But let's see. I have to talk to seniors and senior experienced professors. Let's see.
So it's good that you have selected for the position, and I congratulate you for the same. And for the completion, I just want to ask your hobbies. Do you have any hobbies? So it will be good if you can share the hobbies.
Hobbies, I actually like to do everything. At least whatever I know exists. But I play volleyball, cricket, badminton, and I watch a lot of YouTube videos.
What type of YouTube videos?
Any casual political, not much these days, not these days.
About political things.
Yes, but I am not doing right now because of schedule. We have a very tight schedule, and yes, yes, YouTube.
Thanks guys for watching this Jagdeesh interview. Thanks.